Good morning, everyone. Today we are going to teach you guys about how to use in the Blender physical simulations. We will start with collision and soft body. So first things, we using the Blender 4.2. If you want to completely use the same command, same operation, please use the same version just like mine. Let's press Shift A, create first sphere. And then Shift D, create one more. Let's move this one up a little bit, probably just like this. If you want to see more clear, you can press 3 to see the side view. Okay, right now I think it's quite enough. So I want to make these two spheres have some physical property and they can interact with each other. The first one will be soft body and the second one will be collision body. So this one will crash into the soft body and create some physical simulations. So first things, I have to choose in the sphere, go to the sidebar, and there is a tab which named physics. For the first one, it will be soft body, and for the second one, it will be collisions. Let's take a look. So in order to make them crash with each other, I have to set animation keyframe for the collision object. So that we can use in I or K to set the animation keyframe. For I, it will create all the animation keyframe on all sections. Let's take a look. Okay. But if you want to set animation keyframe on certain location, rotation, or scale, then we can just press we can just press K and choosing the target section. So for this time, I want to use in locations. And now let's move our time slider to 50 frames. And let's set that one more time. Press K, locations. So now let's start to do the physical simulations. Okay, as far as you can see, this one become a fluffy object and it will be crashed, it will be bumped by the collision object. So how it works and how to control the different performance for that. So first things, the very important thing to know that is that not all the physical objects can interact with each other. So for example, right now we are using soft body and the collision and soft body. So for the collision object, it only interacts with soft body, particle, clothes, force field, but not rigid body. Remember, it doesn't work with rigid body. Rigid body, actually, it only works with rigid body and also rigid body constraint. Sometimes particle, okay? So that's a very important thing. If you find out it doesn't work for you, probably it's because you're using the wrong categories. So now let's go to the detail about the soft body geometry. There are so many different things we have to check, but I would say just control the key part and it will be fine. And basically all these key parts will exist in different categories. So once you understand the principle, all the rest things you can understand. So let's go to here. First thing, soft body collision collection. What's that mean? Which means if you want to make this object only works for this group, then choosing a certain collection. Usually for this model or for your project, probably there will be thousands of collision objects. But if you make them all work with each other, it will crash your laptop. So we can choose in collision collection to restrict only this group can work and all the rest doesn't work. So that can help you to reduce and save some power for your laptop. Let's press N and create, I already have, so probably I will just use this one. Let's use in this one. And let's move this one to here and move another sphere to here. So basically right now, both of them are inside this collection. So let's go to soft body collections and let's choose in this collection, soft task. So right now, only the soft task object can work with our physical simulations. Alright, so now let's go to the next part, friction and mass. If we increase the mass, let's see what kind of thing will happen. Basically, because if the mass is getting huge, well, probably this collision cannot move this one anymore. But meanwhile, this one will falling down. Let's take a look. Okay, it's falling down. So if you don't want this one falling down so much, we can go down and go to the field weights. What's that mean? That means what kind of forces can affect this geometry. There are many different kinds of force field inside Blender, including gravity, force, vortex, magnet, harmonic, charge, and all different kinds of force. And if you want the gravity not work, you can just turn this one down. Probably let's turn this one into 0.05, something like that, and start to do that. Okay, so as far as I can see, because we increase the number of mass, so for this one, it doesn't be distorted, it doesn't be pressed that much. It just has really little distortions. That's because we have even more masses. So how about the friction? If we increase this number, it will make the surface more sticky. Okay? And also for collision, for collision object, we also have friction. If you increase this one, let's see what kind of thing will happen. Okay, not that much, but you can see it shake a little bit more. That's because the friction has been increased. So let's make this one down, maybe just 1. And let's go to here. Okay, it has been dragged and stick to the sphere. Alright, something like that. So that's how the frictions work. Let's turn this one back to maybe 5. And also this one. Turn this one back to 0. Alright. So now we know the basic property about friction and mass. And how about simulation speed? Basically, the simulation speed is about the frame, the animation frame of your project. So if you turn this one down, all the things will become slow motion. But for now, we don't need to do that. So I will stop right here. And the simulation start and end. So basically, it will just follow the time slider. But if you want to have a longer simulation duration, then you can extend the number right here. And back out dynamic. That's very important. Because once you finish the simulation, once you finish your animation setting, you can back all this data into a data list. So for the next time, you don't have to recalculate. You don't have to resimulate that one more time. So usually, once we finish this setting, you can back all the data into a data list. So for the next time, you can just using this data list, you do your simulation. And it will save a lot of time for your laptop, for your rendering. So for the next part, very important. The edge, stiffness, and self-collision. I think that's the most important things inside soft body geometries. So what's the pull and push? Okay. Basically, when we are working on soft body, just imagine that there is a push force inside every vertex. They are pushing, and meanwhile there will be pull. Okay, there will be pull. So if we make the pull power larger than the push power, what kind of thing will happen? Let's take a look. Usually we cannot turn this one into 1 or 0.99. Usually I would just set this one probably to 0.98, something like that. So let's see. Okay, so basically when the pull power is bigger than the push power, well, this one, we can actually turn this one even less. Let's try to do that again. Okay, so this one has even more power to inflatten. So it will expand and become a more complete sphere, right? And how about damp? For the damp, it will slow down the shaking performance. So if we increase the number right here, and probably I will turn this one down back to the 0.5 or 0.4, something like that. Okay. And if you want to make your geometry more soft, you can increase the number right here. So now let's take a look. Alright, so once we increase the plasticity, the geometry become more soft and it will be distortions. And also because of the damp, you can see the shaking has been slowed down. Right? And how about the length and bending? Basically for this one, for these two, I don't use them that much. And also for collision, that's very important. Usually, I prefer you guys using edge, not face. It will depends on how the computer calculate the collision and crash. So if you're using face, you will using face to calculate the collisions, and if you're using edge, you will using edge to do the calculations. All right. So for the edge part, if you're using edge, it will save more physical memory for you. Next part, stiffness. What's that mean, stiffness? Basically, it's about shearing power. When we are, for example, when we are working on using scissor to cut off a paper, basically the scissor will have two knives, right? And one going down and another going up. So basically, it will create a shear power, and that will split this paper. And for this one, it's about how the sphere can resist the shearing power. So if you turn this one into 1, it will have a very strong shear power to resist that kind of diagonal power. Okay, something like that. Probably we can turn this one, go back to 0, so that you can see more clear about the power of the shearing. So final thing, self-collision. Basically, that's a very important thing. If you want to make a plastic ball and it has a strong bouncing power, then we need to use this one. So first thing, both sides. You can just imagine all the vertex inside Blender. Well, if you check this one and you make this one bigger, it will create an invisible large ball on the vertex. So once the vertex start to collapse, start to intersect with each other, it will base on this sphere to calculate the intersection and to avoid they intersect with each other. So let's try to do that. Okay, you can see because I turn this one into 10, so it start to inflate. It can be inflating. I think it's too much. All right, let's stop. Maybe just 1. Okay, avoiding the intersected based on the both sides. Alright, so now it doesn't intersect with itself anymore. Alright, I will stop right here. How about the following part, the stiffness and dampen? For stiffness, just like what I said before, it's about the shearing power. But for this time, it's about this ball. How the ball will shearing with each other and how the resistance will happen. So, and for the damping, it's pretty much the same, just like the upper part. So that's the basic understanding about the physical simulation between collision and the soft body. So let's take a look. There is a quick mode right here. Soft body versus collision. Both collision and soft body have frictions, and it can make your geometry sticky. And soft body collision collection. You can use this one to control the working object. Outside of these collections, it doesn't work. And if we increase the mass, smaller and less, I think there's something wrong. It will shake more. And similar simulation speed will make everything become small motions. And the most important parameter I just introduced to you, so you can just follow my tutorial to know how to do the simulation through controlling all these different parameters. Okay, I would say physical simulation is very tricky. Sometimes even you know all these different kinds of stuff, all this what's that mean, it's still hard for you to do the completely right physical simulation. But I would say just try more and test a couple times and you can get the result you want. Right, so that's all for today. See you next time.